Arithmetic sequences and series are one of the most earliest concepts that you'll be covering in the IB Math AA. So let's cover the formulas. U of n equals u of 1 plus n minus 1d gives us the nth term inside of an arithmetic sequence. And the two sum formulas here gives us the sum of the first n terms in an arithmetic series. So let's look at this example problem here, where we are trying to find the sum of the first 20 terms inside of this arithmetic sequence, where the first term is equal to 7 and the third term is equal to 13. So one of the very first things that you should do when you do an arithmetic sequence problem is identify what variables you have and what variable you are trying to figure out. So in this case, we are given that u of 1 equals to 7 and u of 3 equals to 13. And that s of 20 is the variable we are trying to look for. And what we're trying to do here is identify what kind of variables we also need in order to solve this. So if you recall the two formulas we need, you can either have u of 1, n, or d, or you can have u of 1, n, or u of n. Now, right now, we have u of 1, which is 7. We have n, which is 20, but d is unknown. The same way this and this we have, but u of n is unknown. So our job is to either figure out d or u of n. And we just have to look at the question and say, what is easier to figure out? In this case, seems like this information given to us with u of 3 equals to 13 is going to help us figure out what d is equal to. So u of 3 equals to u of 1 plus 2d, which then equals to 13 equals to 7 plus 2d. So that becomes 6 equals 2d, and we see that, therefore, d is equal to 3. And boom, we now have d equals to 3, and we can proceed with using the first formula to figure out s of 20. S of 20 is going to equal to n over 2 times 2 of u of n, u of 1 plus n minus 1d, for which, if you substitute all of the values in, it becomes like this. And quickly simplifying this, we get 14 plus 57, and this becomes 10 times 71, and becomes 710. So therefore, s of 20, which is the sum of the first 20 terms inside of this arithmetic sequence, is equal to 710. Let's take a look at another example here. The question asks us, find the first term, u of 1, and the common difference d of an arithmetic sequence if the fifth term, u of 5, is equal to 12, and u of 12 is equal to 40. Now, our two variables that we're trying to find is u of 1 and d. So I'm going to list that up. U of 1 is equal to question mark, and d is equal to question mark. And we have that u of 5 equals to 12, and u of 12 equals to 40. So what we're going to do is use the nth term of an arithmetic sequence formula and expand both of these out. See what we get. This becomes u of 5 equals u of 1 plus 4d, while the second equation becomes u of 12 equals u of 1 plus 11d. And let's just substitute the numbers in for u of 5, which is equal to 12, and for u of 12, which is equal to 40. Now, we really see we have two equations with two unknown variables, which would allow us to solve for either one of them. So you can use either substitution, or something I like to do more is just subtract by the equations by itself. So this would look like, if we were to subtract these two equations, we would get negative 28 equals u of 1 minus u of 1 is equal to 0, and 4d minus 11d, which would equal to negative 7d. And now we have this equation that we can divide by negative 7 by, and therefore d equals to 4. And to get u of 1, you can use either of these two equations and just substitute back d. So let's just take the first one. It becomes 12 equals u of 1 plus 4d. And since d equals 4, we can substitute this in, and therefore u of 1 equals to negative 4. So that is how we would do this type of question.